But let me give you a quick overview of what we're working on here. Can you see that all right, Matt? Okay.
Looks good. Yes.
All right. So, and there we go. Okay. So at the University of Michigan, we are in the middle of transforming how we do our network. And we're transforming networking in 3 ways, only one of which I'm going to talk about today. But just for context, we're in the middle of replacing our 16,000 Wi-Fi access points. And we're in the middle of replacing our 4,000 network switches as well. So we have a lot of change going on. And so that seemed like a really great time to also automate the network. I say that half jokingly, but I am actually serious in the sense that a major network change is actually a good opportunity to, as you roll out the new devices, to try to do them in an automated way. And so that's what we're trying to do. So we kind of have a little working group that spans some of our software developers and our network engineers within the U of M team. And the basic charge that I gave them was to basically come up with and implement our network automation strategy, figure out how we're going to handle all our legacy infrastructure, and come up with that initial automation. And so that's what we're well underway in terms of doing, and we're going to give you sort of an update where it's at. For context, and the details on this slide don't matter other than it looks like spaghetti. When I first joined the U of M about 4 or 5 years ago, we had a lot of legacy tooling. I think this is common for most universities, with each tool serving as multiple roles, and each tool sort of interconnected to others in sort of a confusing way. And so trying to move away from this 25-year-old legacy infrastructure that had been built sort of in, piece by piece to a single unified system is a big driver for what we're doing. So we basically hit upon the fact that you have to, when in any automation strategy, establish sources of truth. And I'm sort of trying to present this, by the way, from a U of M or a university perspective, and what Karl might be presenting is more from like a national network or regional network perspective. But for us, we basically hit upon, we're going to use NetBox and NSO. When we were giving some of the workshops a couple of years ago that got interrupted by the pandemic, we were pretty focused on NetBox. One of the changes, much like Internet 2, is we've also made the decision to adopt NSO, formerly Tail-F, now a Cisco product, as well. And so that's where we're doing the configuration aspects of our infrastructure. And so basically, a key part of this is the fact that it's not a green field, right? We have a set of sources of truth that exist today, whether we like them or not. And we kind of have to make the decision as we're moving into new network infrastructure. Do we run the new source of truth as a derivative of the old source of truth, or do we reverse the flow at some point, have the old source of truth be a derivative of the new source of truth? Because simultaneously, we all have our legacy tools that are reading off the old source of truth, and we need to know whether to update those legacy tools at what point in time, and all do this within our limited resources. So we're trying to make this migration as efficient and as non-disruptive as possible, but it's definitely a careful logistical plan basically to roll out how do we make all these changes as we go forwards. So a little bit about what we're doing in the NetBox space. So, basically in the past, we sort of had an equipment database for sort of our data center infrastructure management, and we had NetInfo is what we called for our IP address management. And we're essentially pushing these two functions into NetBox going forwards. And so, but remember that most of our legacy tools are still diving into NetInfo and Equipment DB. Obviously, other universities will have their own instance of that. But based on past conversations, I think everybody has some version of a homegrown version of this that they're doing for their information. The NSO migration piece, I think this also maybe resembles what people at other universities are doing well. Currently we're using Rancid for our configuration backups, and our configuration automation is a mixture of Perl scripts and Ansible. But going forward, what we're trying to do is to use NSO for configuration management, and not only for the new access layer switches, but also for the existing ones, is move them in so that we can represent the whole campus network. And all new core and distribution layer switches will also be moved into NSO as well. And so our hope is that, because we're in the middle of replacing our existing Juniper infrastructure with a new Cisco infrastructure, our hope is basically every new Cisco we deploy will be done in this framework. But also, because NSO does a good job of supporting Juniper and other vendors, we can also move our larger Juniper access layer footprint, which we expect to have for a few years, into NSO as well. And so that's sort of the path that we're taking here. And so I keep alluding to sort of our legacy tools. A lot of these tools are written in Perl. They tend to be a mixture of logging into other devices and doing some on-the-fly database creation and the like. And so they're kind of a hodgepodge of different ways to go. And so what we're trying to do is to create sort of a service abstraction layer that better organizes and structures our data, and thus gives us increased reliability and maintainability. And when we were looking at the various different vendors, our conclusion was that that Cisco's NSO product would meet the needs, at least for this generation of the network, pretty well, even though we have a heterogeneous environment. When we were looking at all the different vendors, most vendors seem to have some sort of a product along these lines. Some of the products are specific to that vendor only, like you have a completely homogeneous network, and some of those products seemed more necessary than others. We definitely felt that in the Cisco case, you definitely needed the Cisco NSO product to do what we wanted to do, but that it was a powerful tool once you had made that decision. And I think, Karl may talk about the fact that this is also true for Internet 2, is my understanding as well. So another thing is I want to talk about is, in general, we're not that special, right? There's no reason that we can't run our network conventionally. Yes, it's a big network, but we shouldn't be saying, well, we do it this way here because it's special, and therefore we use tools in unconventional ways. We want to use tools conventionally, and we hope other people solve our problems for us and only solve the problems that no one else is going to solve. One of the areas that I actually think that Silicon Valley is not going to solve for us is, if you're in an enterprise environment, the idea that you would delegate some of the network functions out seems a little bizarre. But in a university environment, at least for Michigan, I believe at other schools as well, sometimes you do want to delegate out some of the network functions to some of the units, but you want to do it in a prescribed way where they can only do so much and in a very finite way. At Michigan, we had a homegrown tool called DCT, for Device Network Configuration Tool, that sort of retrieves the configuration and operational state via SNMP and displays, and then would configure our access layer devices directly via SSH and expect. And this was this giant monolithic Perl app that encompassed both the web front end and the back end communications. And I sort of have a picture here of what it, on the bottom there, what it was looking like. And that's how we were letting the units do their configuration. We don't want to do that anymore. That tool is a pain in the neck to support. And, it can get out of sync with our efforts to move to NSO everywhere else. And so our intent is essentially to create a front-end Django web app that also integrates with NSO, and that also, essentially uses the NSO interface to retrieve configuration and operational state using custom NSO actions. And then we let NSO handle the back-end communication with the devices, and we separate the front from the back. So this is actually an area where we're doing some of the development, because we don't want, this doesn't appear to be an area that Silicon Valley is going to solve for us. A little bit more about this. Basically what we're trying to do is, in addition to this, is use the NSO netconf API, use service models to implement changes into the network. And then we basically create a small set of NSO actions to encapsulate that functionality. So what that might look like, for instance, again, as we're delegating this out is, this might be the type of screen that we present to folks, a web UI that gives users a limited set of options to configure common things like VLAN ID, description, speed, or duplex. And then campus IT administrators can use this when deploying new workstations and printers and the like. And so, when you click on one of them, it will then give you a pop-up that allows you to pick within the limited constraints that we have. And so our hope is with that sort of transformation, it's still using NSO to do all the work. It'll still stay in sync with what the core network team is doing, but we allow this delegation of authority. And our intent over the long run is to actually make this also restricted. So if you're in our college of our business school, you can only impact that subset of devices, et cetera. A little bit more about, oops, sorry, I wasn't showing the slides when I was doing that. So this is sort of our front end here, and this is sort of what that web interface would look like. A little bit about the fact that we are a multi-vendor site, right? So we have, a while back, we were Cisco, and then over the last decade, we've been Juniper, and then we're returning to being a Cisco shop. And so we've got this large heterogeneous environment. When I joined, I think we identified 125 makes and models of switches on campus. So we're trying to shrink that footprint of switches, but we're still going to have these legacy devices for quite some time. And so the NSO capabilities to abstract network device configuration to a hierarchical in-memory XML database, sort of to configure database, the configuration database to allow transactional configuration changes, and the fast feature development cycle are all some of the things that we were looking for in terms of taking this approach. A little bit more about what that looks like. So this is sort of our flow chart in terms of how we would, things are working. So on the left there, you see what the Django app will look like for the web users. At the next stage, you see what sort of the NSO NetSplash API will look like. Then you see what the distribution service model would look like, and then there are the actual devices. And so that's sort of the process that we're using. And over time, we would like more and more of our network operations team also to be sort of going through this model as opposed to getting on the devices directly. That's a big goal for us as well. So let's talk a little bit about that. We also need to figure out sort of what the data flows are. We have this set of Perl tools that our operations team is used to using. We have BlueCat. And so what we're trying to do is, and we've also got the equipment database and NetInfo. And so what we're trying to do is to figure out what the data flows are on an interim basis. So if before BlueCat was talking to the equipment DB, how do they, and to NetInfo, how do we make that work so that the old tools still work for a while, but we start going through the new statements of truth? And sometimes we may end up having the old statement of truth feeding the new statement of truth. And other times we may have the new statement of truth feeding the old statement of truth, just as we sort of plan out those data flows. So where we're at right now is our NetBox migration is in the planning stage. The biggest constraints for us are always lack of developers. So that part's a little bit further out, but on the NSO front, we've got our initial NSO services built, being tested. And we are basically writing scripts at this point to generate the NSO service instance data by parsing the existing router and switch configs. One of the things that we've had a problem with, and I'm sure others do to varying degrees, is we have templates to build our switches initially, but then we get drift. So one part of incorporating existing legacy devices into this new automation framework is also going back and looking at the drift and sort of saying, how do we want to account for that? Do we want to reverse the drift, or do we want to change the model to accommodate the fact that the template really didn't match what we needed? So how much drift should be incorporated into the services or removed is obviously a big challenge as we go forward, and why we're basically going to be tackling this on a building by building basis. in terms of replacing the legacy tooling, I'm not going to go through all this, but you can see we've got a mess of different things to do the various different functions. And going forward, at the end, we should have a mix of NSO, NetDisco, and a little bit of Python as our future tool infrastructure to run the campus network. It'd be remiss if I didn't talk briefly about what the skill set is that we need from our mixture of software developers and network engineers to accomplish this. We're obviously using Git. We're using various flavors of Ansible, NSO, Yang. We're obviously using NetBox. There's a lot of Python training. I put a link up there. It's a really great course for anybody who doesn't have Python experience. It's all self-taught. It's free. Happens to be taught by a professor at U of M, but it's a really good way to get somebody up to speed on Python. And also, a good understanding of software development practices. Some folks are coming out of a software engineering background and know a lot of this stuff, but don't necessarily know the networking that well. And some folks are coming from a networking background and are learning some of the standards for software development. So, everybody's got different strengths and weaknesses that we're trying to meld into a common whole. We're also starting to look at the network as code. And try to use good software engineering processes where we actually, have reviewers that look at merge requests as we change our network itself. So we're really going to move to an environment where you can almost think of the network as software on a going forward basis. This is quite common in the software engineering space, but we're moving to it in our network engineering space. So hopefully that was quick enough to leave Karl some time. And then if there's any other time, I'll take questions at the end.
Karl.
All right, thanks a lot, Eric. Let me find my window. All right, so I actually have another talk related to this coming up, I think at 2:30 Eastern. It's going to go in a little bit deeper. So I was taking this opportunity to sort of keep it high level and also, compare and contrast what we're doing with what Eric and you Michigan folks are doing. Again, I think it's to give you an idea that while there's differences between our, our networks being a service provider versus a campus, there's also a lot of similarities. So again, different problems with similar solutions. So compared to a campus, we have, we don't have a lot of devices. We have less than 100 devices on our network, but we have thousands of BGP sessions and thousands of lines of route policy that we have to manage. And again, we're using Cisco NSO to manage all the configuration on NGI devices. Right now, our source of truth, a lot of it is actually NSO. We sort of decided that early on that it already was a database. So for many things, it's a source of truth, but we also have a lot of our information currently in the global NOC DB, that we use to, maintain information. Also, just high level, people, know that we've been doing service migrations over the past few months. A lot of people have been involved in those. And so, the tooling we use for that is PyATS and Genie, Google Sheets, which might be surprising to some people. And I'll go into that more detail in my later talk. And of course, Python to glue a lot of this stuff together, and especially with the NSO. I wanted to throw this up here because it's a good model. This was sort of a model proposed by some folks at Cisco. It's the network automation delivery model, and I want again, because this is high level, I want people to start thinking about this. It's really about starting small and kind of building up. So you don't need to boil the ocean when you start. A lot of folks are still trying to get into automation, and the best way to do it is really just start. Find something simple. Define it, demonstrate it, deploy it, and then keep iterating on that. And you'll see that's even with having a tool like NSO, which eventually we use to automate our entire network. We started off small, and we've been iterating the whole time. This sort of came up in Mike's talk earlier. What's our team look like? NSO side, we had 4 primary developers for that. Myself, James Haar. Jonathan Stout at the Global NOC, he does primarily does OESS development. So because we are converting and going to use NSO as a backend to OESS, he did a lot of work there. And we also had Jarrett Eck as a contractor paid for by Cisco and GDT. But a big part of this, and I think something, a key takeaway to how we were so successful, is that we had an integrated team. There wasn't just a team of developers, developing in a vacuum. We had tight integration with the network engineering team. So we had a design team with Mark, Jeff, Matt, and Andrew. We meet once a week. We talk about service model designs, and we iterate over that. And we get an idea of what they want. We put it together. We go back in front of them and say, does this work? And they're also now doing some of the development themselves. And we kind of foresee a future where, depending on what needs to happen, the network engineering teams can go in, make modifications to the NSO models, and then review them with the team. And honestly, there's too many people to name everybody here, but others have been involved in this, especially in the migration process. Ryan Harden did a lot of the PI-ATS verification tests, which I hope to cover some more detail on later. Molly Bayless, who's really an expert on the global NOC DB and helped us extract information from the network. And then just the network engineering team. They were guinea pigs for a lot of this. And I think they latched on to NSO pretty quickly and had a good experience with it. Eric talked a lot about, how the challenges they have with migration, especially all the tools they had, and trying to figure out how to, and having a very diverse network. The contrast here is we got pretty lucky. We've got to build a greenfield network. So essentially you start from scratch, deploy a whole bunch of new devices in parallel and migrate the network over. So a lot of our work really was in, how do we figure out what our services are and create models with NSO, and then how do we extract the services from the legacy network and get them into NSO? So when I say services, I'm talking about things like your RNE peering, I2PX peering, all the OSS circuits, and any of our BGP peerings with our commercial providers. So it's basically a ETL process. And so again, this is where Molly Bayless was heavily involved, and James Haar. So, Molly was writing scripts to pull, basically extract those services from the legacy network live from the devices. So we weren't, so we're actually making sure we were getting, things that were actually configured on the devices, augmenting that with metadata from the DB, and then essentially putting that into a CSV. And we'd import that into Google Sheets. And then James Haar put together a bunch of Google Apps Script, which is JavaScript. And that takes all of that information, combines it with some of the information from NSO, and essentially spits out NSO configurations for the engineers, and also spits out some of the data they need for service validation. And again, later, my talk later on will provide a little bit more detail on what we're doing there. And then a really big part of this that really helped us to succeed in our migrations was validation tooling. So, we had, I think for manual BGP session migrations, this was engineers doing the work. We had close to 1,000 sessions we had to migrate over a couple of weeks. And actually, that would have been impossible to do without automation. So without NSO being there to do all the config management for us, but we also have these validation scripts that helped us, make sure that after we migrated a service, things still look correctly, and anything that was problematic, we could quickly identify. So again, these were written by Ryan Harden using another Cisco product called PI-ATS. This is open source. Basically, the script would, prior to a migration, would log into the Juniper routers, pull information on the BGP session, like prefix counts, and actually all the prefixes, and store them. We'd migrate the service. We'd run that script again against a Cisco network. It'll pull the same data, prefix counts and all the prefixes, and then you'd run that script again with a diff flag, and it would spit out any differences in what happened. And using that, we could quickly identify where we might have an issue. If we accepted routes before and we're not accepting them now, we have an issue, probably in the route policy. And this really helped in the beginning, because also in the beginning of the migrations, we started off slow. We did a few at a time, and then we'd kind of exponentially increase that, do a few more and then do a few more. And so figuring this out early on helped us identify where we had issues in our route policy and fix that before we moved on to migrations where we're doing, 50 or 100. And I think in one of our largest nights, we did close to 200 migrations in a night, which was a challenge, but it, actually went really smoothly. And our validation scripts helped that. So again, it's just thinking about upfront when you're doing these big kind of migrations and automation. Think about what other tooling you can build to help you automate that, not just the configuration. Just to give a quick overview of where we're at. I mean, this isn't all the models we have in our network. We have about actually 30 models, 19 of which are edge member facing that we use to configure the network. So basically, to configure the node itself, that's all your kind of baseline configuration. Configuring interfaces and sub interfaces. These were sort of all the first ones that had to get done, and then bring up the backbone and the shims. And now we have services for all of our peerings with our members, with our peers. And as Mike mentioned in his talk, we'll be working on, bringing these into NS Console and exposing these, at least initially, give everybody a bird's eye view of what their services are. And then eventually turn that into, being able to allow you to modify your services and provide more information about service state. Again, I guess I covered some of this, how many models we have. We have over 3,500 service instances in NSO, right, and that are being managed by NSO. I think what's cool is, 32,000 lines of NSO service config. That's like how many lines are, either were copied and pasted in NSO or manually input by engineers. But that results in 240,000 lines of device config out there on the network. So this is showing how much we get out of a tool like NSO or other automation tools. On the DevOps side, we've had 1,400 commits to the repo, 480 merges into it, and we have an automated build pipeline, which I can provide more detail about in the other talk. We have 4,000 builds going in testing and fully automated testing, so we can catch bugs before we would roll them out to production. I just want to mention this high level. We brought it up before. We have had conversations with not only with Cisco, but with some of our members offering NSO as a service. Again, that's still a work in progress. We don't know exactly what that would look like, whether that's Internet 2 hosted or some kind of pricing model. But again, if people are interested, please reach out to us. We need to gauge the level of interest, talk with the community, and then talk with Cisco to see how we could offer this. Just to kind of recap or wrap this up, the lessons learned, start early. I think everybody knows that or thinks about that and wishes they could. It definitely helped us. I still say I wish I started earlier. I mean, we started back in early 2020 with NSO development, and we've gone through a lot of iterations and iterate. What you build day one is not going to be the same thing as what's deployed months down the road. We've completely redesigned it multiple times, and again, that helped by starting early. We needed to figure out NSO, and we would tear it down and start over, and we're still iterating. The models as they are right now are going to change. And again, the thing I can't emphasize enough is integrate your network and development teams. This was huge for us. It helped us succeed. It helped us get buy-in for NSO. And again, those lessons learned are also my recommendations. Integrate your teams. And I think this is really this is for everybody, but for the CEOs, the CIOs, the CTOs, the managers out there. Automation is here. Software development for networks is here. You need to start training and hiring DevOps engineers and software developers. You're going to need those folks on your team. So if you have an opportunity, if you have an opening, look for those skill sets or hire explicitly. And I'll just throw out there, I'm here to help. Mike and the rest of the team is here to help. If you want some, guidance on, positions or what job descriptions need to look like, we need help with hiring, let us know. We'd be happy to help. With that, that's it. I'll wrap it up and see if there's anything in the chat.
Yeah, I don't see anything in the chat. We have got a minute or so. So if there are any questions for Eric or Karl that people want to bring up here, now's the time.
I have a question, particularly for Eric. So in a software development world, you have development, test, QA, and production instances. Are you of the software and the environments? They're not all equal, but you have those. What do you have along those lines, or is everything being done in the production instance?
No, we're actually trying to mirror that. It's a great question. And I'm not saying we're perfect here yet, but ideally, what we're trying to do is we have a development instance in our lab that people can work towards. We treat our ITS buildings as a separate network from the rest of campus. And that's sort of that QA environment in a sense. Eat your own dog food, kind of, basically try it out there. And then and only then roll it out more broadly. And when we roll it out more broadly, if possible, if we can limit the blast radius, like do it on a per building basis, then we will do that. But we've generally taken that, lab, IT buildings, campus approach for a lot of different things.
So
likewise, when we upgrade the Wi-Fi infrastructure, we have separate controllers and we do the code there.
In that kind of models, and so is prod or is test and devs kind of together, or?
Yeah. So test and dev is kind of in the lab, right?
Okay.
And then essentially we have a beta environment, which is our IT buildings, and then our production environment, which is campus.
Okay.
But there are some things where we will be able to roll out changes like automate on a per building basis, and we will do that as well as a way to sort of minimize the blast radius again.